Dynamic arrays, the new way of doing things. So what has changed? The arrays can be set by a live variable within the program. That's one of the biggest changes that we have. We can also, by the way, resize things, and we'll talk about that later on. We didn't have that ability when it came to stack arrays. The other thing that's changed is now, because we're using a different type of memory, we actually have to deallocate the memory and basically say, hey, computer, this is done. You can reuse it for something else now. That's very different than what we had in the stack arrays. And then we have to set the name of the array to a null pointer. Now, we've actually seen something like that before, but now it's for safety's sake. And matter of fact, I'll show you down the bottom on how to do that here in a moment. What hasn't changed? Editing the values hasn't changed at all. So that part, you're not going to see a lot of code from me on this particular set of notes when it comes to that. So just a heads up. Both are using pointers. It's just where in the memory are they being stored, and I'll cover that here in a moment. So I brought it up before. But anyway, declaration of a dynamic array. Nothing crazy, but you're going to start seeing the new command. That's literally letting us know that we're creating memory on the heap that's going to be of an integer type. Yes, it's going to be a pointer, but we knew that already with just normal stack arrays. And then we're going to give it a length of size 21. By the way, that could be a variable. As long as that variable is defined as the program is running, fine. But so I don't want you to think that had to be a value in there. It can be a variable that's defined somewhere in the program, fine. Like these here. So these are creating matrices, and this looks very different than what you had. Well, here's the bad part. When we're doing it this way, number one, you see a double pointer. Because think about it, and I'm going to show you another picture here in a little bit. You're going to have one that goes for the rows, the other one for the columns, and that's literally how this is breaking up. It's taking care of all the rows first, and then it's creating all the columns afterwards. So it is a literal process on setting up the matrix. Notice the exact same thing if we're using any other object that we've created, custom objects, structs, classes, whatever. We would have to do the exact same thing. So this is the physical setup of literally physically putting those blocks together in memory for a matrix. And that's why it's not super complicated, but at least it's 3 or 4 lines. Again, editing, no difference. When I am done with my application, I need to delete the memory, so we return it back to the heap of the computer. In this, you'll notice a very similar for loop to what we had before, because this one is taking care of a matrix named arrays, where I would have to delete all the rows and then take care of the last part of it when it comes to columns, rows, all that stuff again. But the last part is that we set the names, which is the name of the actual matrix in this case. I set that to null pointer, because otherwise we still have the names variable hanging out there, and it's not pointing to any memory, but it's kind of hanging out there. So when we set it to null pointer, we're giving it somewhere to directly point to, and frankly, to make things safer. So that's called a dangling pointer if we do not do that last step. So notice there are definitely some differences. Now, here's a nice part. Copy and paste this for your matrix, change the names, and boom, you're done. That's how easy that part is, so that's a good news. So a lot of this copy and paste, but it is different than what you had in stack